you're welcome to my YouTube channel. And in today's video we're going to be considering a material balance problem. And then the problem says fresh watermelon juice containing 7% solid is concentrated. Now the fresh watermelon contains 7% solid, and so if it contains 7% solid, that means the amount of water in it is likely to be 70, so it's likely to be 93% water concentration. But in this case they say that the fresh watermelon juice containing 7% solid is concentrated in an evaporator to 50% solid if the juice is entering at 500 kilogram per hour. Now the question is, calculate the amount of water removed and the concentrated watermelon produced. So now we are going to be looking at three things. The first is the fresh watermelon. Initially the question says that it contains 7% solid, and now when it was put in an evaporator, it was now concentrated towards 50% solid. Now if it's concentrated, that means that it lost water for it to be concentrated. And now the question now says, calculate the amount of water that was removed for the juice to be concentrated, and then the amount of concentrated watermelon juice. So now the first thing we are going to look at is to set a system for our problem. Then when we set a system for our problem, then we'll now form the corresponding mass balance equation and the component mass balance equation. So now the first thing is solution. Now the question says fresh watermelon juice. So now in our system that we have, now the question says fresh watermelon juice containing 7% solid. So what entered if the juice is entering? So now what entered into the system was fresh watermelon. So we have fresh watermelon. Now the fresh watermelon is containing 7% solid. So we have 7% solid. 7% solid, and then the system is that's concentrated the solid is an evaporator. It's an evaporator. And then they said that it was now concentrated to watermelon produce. So we now have a concentrated watermelon juice. So what came out was concentrated watermelon juice. And then the amount of water that was removed. So another thing that came out is water vapor. Now the juice was entering at the rate of 500 kilogram per hour. It entered at the rate of 500 kilogram per hour. And now the concentrated watermelon juice, now when it was concentrated in the evaporator, became 50% solid. Now it became 50% solid. And so in this question, now we've now gotten our system Now the fresh watermelon contains 7% solid, and now it was now concentrated in an evaporator to what? 50% solid. Now, for it to be concentrated, that means something was lost. And what was lost? That is water vapor. So now the question now says, calculate the amount of water removed. That is this. And then calculate the concentrated watermelon what? Juice. That is the amount. And so in this question, we are going to designate this, the fresh watermelon with a letter, designate this with a letter and this with a letter, so that we are going to be able to, so that it will be easy for us to form our mass balance equation and our component mass balance equation. So for the fresh watermelon, we designate it with what? F. For the water vapor, we designate it with W. And then for our concentrated watermelon juice, we designate it with what? With C. And so the first thing we are going to look at is our overall mass balance equation. So we have now our overall mass balance equation. And so the overall mass balance equation is F, which is the fresh juice, is equal to, now the concentrated juice that was removed from it, and then the water that was removed from it. So we have F equal to C plus, we have what? W. And so they now say that the first watermelon was entering at the rate of 500 kilogram per hour. So now the mass per hour of the fresh watermelon is what? 500 kilogram per hour, which is equal to, now remember, concentrated watermelon juice, the amount is not known, and for water vapor, the amount is not known, and that is what the question says we are to what? To calculate. So this now is now equal to C plus W. We call this our equation 1. Call that our equation 1. And now the next thing we are going to look at is the component mass balance equation. Our component mass balance equation. So I'm going to wipe this first part. No, wipe this first. And now the next thing we are going to form is our component mass balance equation. So we now say component mass balance, our component mass balance. Now remember, they say that 500 kilogram per hour was entering the evaporator, and then it contains 7% solids. So that means 500 times 500 times what? Sorry. Now our component mass balance equation is, we have F, the mass times the percentage it contains, and that is what? 7% was equal to, now the question says that 50% concentrated watermelon juice was produced. So we have watermelon juice, which is C, was 50%. So we have C times 50% watermelon juice. So we have C times 50% watermelon juice. So continuing from the components mass balance equation, now what we now have is F. Now the mass balance for the fresh watermelon is entering at the rate of 500 kg per hour. So we have 500 kg or 500 times 7%, that is 0.07, is equal to, now C, we don't know the mass, so now times 500 times 50%. So you have C times what? 50 what? Sorry, 50%, that is 0.5. And so in this problem, we're going to get C now. We're going to calculate for C. And so 500 times 0.07 is what? 35, which is equal to C times 0.5. And so in this way now, we're going to make C, and so C now equal to 35 over what? 0.5. And so C is now equal to 35 divided by 0.5, that will give us 70 kilogram per hour. And so the mass of the concentrated watermelon juice, or the amount of concentrated watermelon juice, is now what? 70 kilogram per hour. Is now what? 70 kilogram per hour. Now 70 kilogram per hour. Now from our overall mass balance equation, they say that the mass of freshwater juice is equal to the sum of the mass of concentrated watermelon and the amount of water that was removed. And so we know that the amount of concentrated fresh watermelon was 500 kilogram. And so what we now say is substitute C equal to 70 kilogram per hour into equation 1. So we substitute this into what? Equation 1. And so our equation 1 says that this is equal to this. And so 500 kilogram per hour is equal to C plus W. And so we have equation 1 to be 500 kilogram per hour is equal to C plus what? W. And so we are going to substitute 70 kilogram per hour in C. So we now have that 500 kilogram per hour is equal to 70 kilogram per hour plus W. And so to find W 530